Yeah, today I'm going to present our topic that was related to comparing different machine learning options in open source softwares to mark bark beetle infestation in Croatia. Content of the presentation should be something like that. So with short introduction, I will explain some methods used, study areas, data sets, and we will see results. Basically, what is remote sensing? Everybody who is dealing with knows that this is the process of acquiring information about an object or phenomenon without making physical contact with it. And basically, one of the most important applications, we heard it in last presentation, is classification, which is the process of categorizing objects or areas based on their characteristic in acquired data. Basically, today mostly used machine learning algorithms are neural networks, support vector machines, or random forests, but we dealt with some other also. We discussed different ones, mainly in paper, not here in presentation because of the time limitation. We decided their strengths and weaknesses and their suitability for different types of remote sensing data or specific tasks. Why we decided to map this bark beetle infestation? Basically, these bugs are really nasty ones, and when the trees are not healthy as should be, bark beetles are just, let's say, the drop that breaks the glass, because after storm events or something like that, bark beetles are chewing or the bark, and basically their results in yellow treetops or red treetops, and the forests are basically done. So in order to avoid it, stakeholders or someone who is responsible for the forest should be able to react in a proper manner in a short amount of time in order to cut those infested trees and to avoid spreading of the bark beetles. And the easiest way to map these areas is by remote sensing techniques and using support vector machines. Study area is in the mountain region of Croatia and is basically above here, Rijeka. It is in the municipality of Čabar that is located above around 650 to 1012 meters above sea level, and it's covered in spruce and fir forests. And basically during 2014, bark beetle infestation outbreak was registered. Public authority of Croatian forests, which is dealing with this forest, we knew exactly where these infected trees are, to later establish connection and to prove whether some machine learning methods are better than the others. We used Copernicus Sentinel multispectral imager with turn-to spectral bands, and date is in the beginning of the August, where there are none cloud coverage, and basically because of it is in August, healthy trees can be distinguished with infected forest. So main idea was, since everybody who is dealing with QGIS or SAGA GIS, if you go to imagery and machine learning, you get series of options for machine learning data, and average users or starting users don't want to know much, or are trying to do some stuff with it, with the imagery, and get some results. We've seen it in different municipalities in Croatia that they are using QGIS, they're producing bad results, and they're selling it to the other stakeholders. So I put myself in the position, okay, I don't know much about it, so I will try to download it and prepare it, and just with random sets of machine learning methods in SAGA GIS to develop and get results and see what I will get. Basically, so we used QGIS and SAGA to map and to program this paper. Which method did we use? We used first maximum likelihood, which is supervised classification based on Bayes' theorem. It is a statistical method, and it is really easy to use. There are not much parameters that could be used, and it's a really short processing time. I like this method a lot. Minimum distance is similar to maximum likelihood, but it depends on training data used to perform classification on unknown data sets to the classes that minimize distance between images and classes in multidimensional space. One of the most commonly used and maybe one of the oldest machine learning methods is artificial neural networks, which are basically nodes and should represent how our nodes in our brain functions. So basically the final layer of neurons produces the output, which is typically the classification label. Decision tree, general predictive modeling tool, it is really simple. Entry level, let's say, it is the one of the most widely used for practical methods for supervised learning, and it could perform classification and regression tasks. Nearest neighbor, also basic, but significant, maybe more for data processing of textual data, but it is often used more in pattern recognition, data mining, and intrusion detection. Random forest is basically also one of the mostly used, and it is a combination of multiple decision trees where the algorithm is trained on different multiple decision trees with adding this randomness into the variables, so basically it improves the classification results. We used also support vector machine, of course, also one of the most used supervised learning algorithms, and the main goal is to seek to find a hyperplane that separates the data into different classes with the largest margin between the classes. Okay, and the last two ones that we used, one is a spectral angle mapper, which calculates the spectral angle between the different pixel spectral signature and the spectral signature of a known target used to determine its class membership. Basically, it calculates the angle between the pixel spectral signature and the spectral signature of each class and assign the pixel to the class with the smallest angle. And the last one is naive Bayes. It is a probabilistic machine learning algorithm based on Bayes' theorem, which describes the probability of hypothesis given some observed evidence. And each pixel is represented as a vector of input features such as spectral bands or texture mixtures measures. For the accuracy assessment, we used only kappa value and error matrix, but limitation time I didn't put error matrix here. But basically, kappa values between 0.4 and 0.6 indicate moderate accuracy, and above 0.8 indicates very high classification accuracy. Basically, we expected that support vector machines, neural networks, and random forests should produce better results. It was surprising that basically, the green one should be healthy forest, so we had only two classes. We didn't classify roads, households, etc., but we just focused on this area where it's only forest to see where this is infected or not. As we can see here from our results, I mean, I will just pass different classification results. It could be concluded that the support vector machine got the lowest score, but it shouldn't be like that. So basically, later in conclusion, I will reflect why is that, why that happened probably. And as expected, artificial neural networks produces the highest classification accuracy, and random forest was also there as it was expected. So this is for support vector machine, everything is red. So basically that everywhere, even where it hasn't been detected as forest, should be like infected. Okay. So methods have similar kappa values, therefore we could conclude that they have similar accuracy. Higher results were achieved using artificial neural networks, but the results are highly affected by the training data set, the number of training data sets, the control data sets, and the size of specific data set or specific sample, which have a great effect on classification results. However, for many methods, it seems that all parameters have similar effect, because with support vector machine, you can select different kernels or functions. With artificial neural networks, you can train how large the network will be. And in SAGA GIS, this is some basic level that is, yeah, I forgot to mention that we worked on OpenCV library, so all the data should be the same. And so basically, similar effects, but shows that the further research needs to be provided to establish connection between parameters and classification results. This was just general idea to show how would it look if someone who doesn't have much experience, but you know, this open data is coming, free satellite imagery, etc. And we have seen it before, so hopefully this shows that even though if they use some of this classification, that should produce some quality results. Future work, I believe it will be future work, should include that we will work on it to detect how training data samples and the size of the training data samples affect the classification results. Okay, I believe that is it. It was short, under 10 minutes or more.